Hello guys, welcome to second law of thermodynamics, Carnot engine. So Carnot engine is an engine which was proposed by a scientist named Carnot, which works on source to sink. So here in his system there are four working parts. So first is the ideal gas taken in a cylinder like this, and here the walls of it are insulators. These are insulators, and this is a conducting wall. Sorry, the walls are insulating. This is the conducting part. And now we have source at temperature T1, an insulating stand, and sink at temperature T2. Now I'm going to draw the Carnot cycle for a graph and then explain the graph. So first we have the pressure volume axis, and first we have temperatures like this: temperature T1, temperature T2, and we have a point A with pressure PAVA going to, let's say, I'll make it larger. Temperature V, this is always declining by the way. Pressure Now here we have temperature T1, but first we explain it with 4 steps. First is isothermal expansion. So in this step, the system or the cylinder is kept on the source. So this part is kept on the source, and thus the ideal gas gains some energy, which is Q1. So Q1 heat is gained by the system, and here the it expands isothermally. So that means that it expands keeping constant temperature at T1 of the source of the temperature. So it expands from A to B, let's say, at pressure PAVA to PBVB. Now, in the second step, it is known as the adiabatic expansion. So in this step, the cylinder is taken after the source and into the insulating stand. So here, even though that any heat isn't being applied to it, the compressed or the expanded molecules still expands without the presence of heat. So it goes to temperature T2, so the temperature decreases while still expanding a little bit from B to C. Now at C, we have the third step. So I'll write it A to B, B to C. Now it is the isothermal compression, which is C to D. Now in this step, the cylinder is taken into the sink, thus it loses heat. It loses heat Q2 like this, and it compresses to a point D. So going from PCVC to PDVD. Now on the fourth step, it is adiabatic compression, which goes from D to A. So in this step, the cylinder is again taken after the sink and into the insulating stand. And because of the compression, the temperature, which is the temperature essentially rises due to the still ongoing compression, and thus it goes back to point A, and thus the Carnot cycle loops back. So source taken out, insulating stand taken out, sink taken out, insulating stand. So I have formed a kind of a tongue twister to help you remember. Source, stand, sink, stand. That is the 4 steps. Source, stand, sink, stand. So essentially the cylinder is taken to the source, then stand, then sink, then stand. So it goes from isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression. And this is the Carnot's graph. And in the next video I'll be doing the expression for efficiency. For here, efficiency is equals to 1 minus Q1 by Q2 into 100%, and I'll be deriving the expression in terms of T2 and T1 and T2. If you have learned something new, please like and subscribe. Thank you.